Hi, everyone. I want to talk to you today about research methods, research questions, and hypotheses. The research questions and hypotheses are there to help explain the purpose of a study and research and to guide the research. A basic model for quantitative and qualitative research following the scientific method starts with a research question. So, what is a research question? A research question basically is an idea that you come up with about a problem that you want to solve or something that you want to investigate, something you want to look into. An example would be I want to know if men are better at math than women. I want to know if women are smarter than men, stuff like that. I want to find out, is drug A better than other drugs? So we start with this question. Then we start to develop a theory. Well, the question has to come from somewhere. It just doesn't come out of thin air. Most research is what we call incremental research, means it builds upon other research. Very rarely do you find a unique problem that's just isolated in itself in the world. So the first thing we do is we want to develop a theory about our question. We usually do this by looking at other research, seeing what other folks have done, what's out there, a literature review. We go to the library and we find some information and we start narrowing our topic down and getting some thoughts on what do we really want to look at? What can we investigate? What's going to be our unique focus? From there, we want to identify the variables. So if we're looking at drugs, and to say we're a pharmaceutical company, we want to look at a new drug. So we're looking at the drugs that exist, let's say blood pressure medicine. So we look at several blood pressure medicines to see how effective they are, and we come up with a new medicine and we want to know, is it better? So our variables for our study will be perhaps the various drugs that we want to look at, our drug, and we'll probably, often in medical research, they have a experimental design, so which we'll get to later, but experimental design where there's a control group that doesn't get any medication, and there's an experimental group that gets one or of the different medications. So that's just an example of how we'll identify variables. Variables will be the intervention, the medicine, and the groups that we're looking at that we're interested in. That's just one example of the type of variables. And then we want to focus in and identify our hypothesis. So how does a hypothesis differ from a research question? A hypothesis um, is a very focused declarative statement about variables such as the new drug, we'll call it drug A, will lower blood pressure more effectively than the old drug, drug B. A problem cannot be solved scientifically unless it's reduced to this hypothesis form. We have to come up with something very specific and testable. Um, a hypothesis needs to be clearly stated, testable, and neither too specific nor too general. So if I have a hypothesis that's too general, it's easily solved. If I say men are bigger than women, that's so general. There's so many ways that's possible that it's just too general. If I'm too specific, I may not be able to find enough sample. If I want to look at a very, very, very specific argument, it may just be too much. So right there in the middle is a good hypothesis statement, something that's clear, it's testable, and it's easy to put statistics to. And the purpose of the hypothesis is to make a prediction. So with the medicine example, we're trying to predict how our medicine will do compared to no medicine or other medicines. Um, and one thing to always remember, and very few people recognize, is that even if the hypothesis is proven false, it's valuable. If we're looking at our new medicine and it's not any better than anything else, then that's something important to know. It may be that we want to change the medicine. It may be that we want to look at a different sample. Maybe the medicine is very appropriate for a different sample than the one we have selected. Maybe it doesn't work. So that's important to know. So the next step after identifying the hypothesis is to test the hypothesis, and there's a lot of ways we can do that. quantitatively, qualitatively, many different methods. We're going to focus on quantitative just for this argument. Um, and there's different types of hypotheses. So a hypothesis can be directional or non-directional in nature. What does that mean? So if I have a medicine A, and I want to know, is it different from the other medicines? Is it better? Is it worse? I don't know. I just want to see if it's different. That's not a direction. I don't know which way it's going to go. I have no idea. I just want to test to see, does it work differently? If I have a directional hypothesis, which would be more likely, thinking about medicine, I think my medicine is better. So I want to test the hypothesis that my medicine will work better than the other medicines. So that's directional. That's the direction I want it to go. I expect it to go. Hopefully that makes sense. Um, Another example of non-directional, I have a test that I give out at the end of a statistics course, and I want to know, do men and women score differently? Well, I have no idea, no preconceived notion, no background to determine what is the difference between men and women. I just want to know, do they score differently? Or from my experience, I may realize that women seem to do better on the exam for some reason. So I want to see, is that still the case this semester? So I will test with the hypothesis, the directional hypothesis that uh, women score higher than men, and I'm going to test that to see if that's true. It's also known as one tail and two tail. We're not going to really get into distribution, but one tail is directional. I know the direction I want it to go away from the average, and two tail is, I don't know which way it'll go. So that's creating the research hypothesis. It's very important to guide the study. When you're actually doing the test, the statistical test in this case, you'll have a null hypothesis and an alternative hypothesis. The null hypothesis is what the test statistic actually tests. The null is that there's nothing going on. There's no difference between men and women. There's no difference between the drugs. There's nothing going on. The converse of that is the alternative hypothesis, which we will say there is a difference. There's something going on. If it's non-directional, we don't know. If it's directional, we'll say men will do better or women will do better. So that's how you formulate the null and alternative hypothesis. And then we evaluate the results. So we pick the statistic that's going to go with our study, with our sample, that makes sense to us, and we test it to see what happens. And then the most important thing about all of this, when you get done with a study of any kind, is to critically review what you did. Were the methods sound? Was the sample big enough, strong enough, random enough? There's a lot of things to consider when reviewing the research to see what's going on. So typically at the end of your research, and you'll read in articles, they'll have some delimitations, things that were done well, things that were looked at the right way, and you'll have limitations, some problems. For example, let's say I'm a professor in a psychology department, and it's really easy for me to get undergraduate psychology students to participate in my studies. It's very common. We do it all the time. So what's the limitation? Well, the limitation is I'm sampling a convenient sample, a sample that I can get a hold of very easily. They're all pretty much freshmen, psych majors. So you see that could be a limitation if I'm trying to talk about the whole country or a larger population. So you need to really think about those things. Was the statistic that I used the best one? Was the method I used the best one? Did I sample appropriately? So to sum it up, most research projects share the same kind of general structure. And you can think about it in an hourglass shape, beginning with the broad question, the research question, very general statement of what you want to do, what you're looking at. And then you narrow it down, you focus in, you operationalize this question into a hypothesis, this declarative statement of this is what I'm going to look for, this is what I'm going to test. And then you observe it by collecting data. You analyze the data using the statistics of your choice, whatever you decided was the best. You reach conclusions, and then you talk about the conclusions. You sum them up, you generalize them back to the questions. And that's the research process.